students, with the next video of kinetics. I became late, I know, but I will continue anyway. Okay, so this session is also regarding the numericals only. Okay, first look at this question. Nitrogen pentoxide decomposes according to this given equation. It's a first order reaction. Temperature is given as 40 degree and data below are collected. 0 time concentration, see here, N2O5 square bracket. So don't get panic with the table and all. Look at the table clearly, then you will understand what it is. Time is given, corresponding concentration is given. So 0 time, the concentration given is 0.400. So that we can take it as R0 value, 0.400, because it is the concentration at time t is equal to 0. Okay, then different time interval and different concentration is given. Our task is to calculate the rate constant. See, rate constant we have to calculate. For since it is a first order reaction, rate constant equation we know 2.303 by T log R0 by R. This is the equation for rate constant. Okay, now first here, since different time interval and different concentration is given, we can actually choose any set of values. R0 will be always same because it is the concentration at 0 minute. Okay, that will be always fixed 0.400. Then if you are taking the time as 20 minutes, suppose I am taking the time as 20 minutes in this equation, time I have to substitute as 20. Then log R0 is always the same because it is the concentration at 0 minute 400, and since I have taken time as 20 minutes here, the corresponding concentration will be R 0.289. I am not solving the question here. When you divide, you will get a value. That value's logarithm we have to find. We don't have to find, actually in the question paper it will be given. Okay, then you multiply, you will get a value for K1. Similarly, at another time interval, for example, if I am taking time as 60 minutes, so another rate constant we can calculate. 2.303 by 60 is equal into log R0 is always same, and at 60 minutes look concentration is 0.151. So you will get another, again you need to solve another rate constant value you will get, that we can take it as K2. Okay, now one more value for K we can find out because different data is given. Let me take it as 80 minutes. So why I am taking it 80 minutes? See, these are the time intervals given here. So from that 2-3 time interval we take, corresponding R value also we have to take and calculate log, sorry, K. Okay, R0 is always same because it's the concentration at 0 minute, 0.109. So another K value you will get. Now we have K1, K2, K3. It will be almost the same value. Okay, so small difference can be there. So you have to take the average of that. Okay, so when you are taking the average of that, you will get the rate constant for this particular reaction. Clear? I hope it is clear. Now next question is, what will be the concentration of N2O5 after 100 minutes. Okay, so now what do we have? From the first part of the question, K value we got. Here the solution is given in the slide. So average K value we got it as 1.624 into 10 raised to minus 2 per minute. Because it's a first order reaction, unit will be time inverse. Time over here is in minute, so minute inverse. So K value we have. What will be the concentration of N2O5 after 100 minutes? Time is given as 100 minutes. So concentration after a given time, that will be R, right? Concentration of N2O5 only they are asking, that is R. And we have the equation K is equal to 2.303 by T log R0 by R. R0 is 0.400 only, and this one is R. That we don't know, that only we need to find out. Okay, here time is 100 minutes. Okay, so now how do you find it out? This value we have, so just make this term alone here. So log 0.400 by concentration of N2O5 is equal to 100 into K's value is this 100 transposed and it went to the numerator. 1.624 into 10 raised to minus 2 divided by 2.303. Then this now we have 100, 10 raised to minus 2 went off, 1.624 and 624 divided by 2.303. Both the equal number of decimals they have, so we can divide it 1.624 by 2303. Okay, let me calculate. 1.624 divided by 2303 is 0.7051 we will get. That is for this one, log 0.400 by N2O5. Now the task is we have to find this logarithm, we have to remove. So if I remove logarithm here, the opposite side you have to find the anti-log value, anti-log of 0.7051. Again, don't worry, as the table is not given to you, you cannot find the anti-log using the logarithm table. Okay, they will be providing the anti-log value in the question paper itself. Okay, so when calculating the anti-log value, I'm just referring here 0.7052 anti-logarithm is 5.072. So this is 0.40 by N2O5. So 0.400 by concentration of N2O5 is found to be 5.072. So when we are finding N2O5, it will become 0.400 divided by 5.072. So the answer is given here 0.789. When you are dividing, this answer you will be getting. I just took the answer and kept because so that the division time we can save. Otherwise again time will go. Okay, clear? This part how to solve is clear. Then third part of the question is calculate initial rate of the reaction. So rate of the reaction, how do we calculate? For first order reaction only. So rate is equal to K into N2O5 raised to 1. So but here you see different time interval and different concentration is given. Since they are telling initial concentration, we have to take the concentration in the initial time. So K's value we got before 1.624 into 10 raised to minus 2 and initial concentration is 0.400. So when you multiply, you will get initial rate. Suppose if they are asking rate at 40 minutes, then concentration of N2O5 you have to take it as 0.209. Clear? Now we will move on to the next question. Okay. First order reaction takes 23.1 minutes for 50% completion. So time taken for 50% completion, that we can write it as T 50%. 23.1 minute, right? What do you want to calculate? Calculate the time required for 75% completion. We have to find out. Okay, so T 50% means 50% of the reaction completed. 50% means half of the reaction completed, right? So this 23.1 minute is T half. Okay. Now say T 75% we want to calculate. 2.303, since it is first order again, 2.303 by K log R0 by R is the equation we have to use. Okay, here R0 we can take it as, I always say, since it is given in percentage, R0 we can take it as 100. Okay, and 75% completed means out of 100 75 completed. So how much is remaining? 100 minus 75, that is 25 will be remaining. And remember, R is the amount left after a given time interval. Okay, so R0 is 100, R will be 25, and we don't have K. Since T half is given, K can be calculated as K is equal to 0.693 by T half. Why I am choosing this equation? Because it is a first order reaction. Okay, so K's value is 0.693 by T half, that T half is 23.1 minute. So this we can substitute in this equation. Okay, since they didn't ask the K value directly, we can take this out and substitute. Okay, so 2.303 by 0.693. 0.693 is coming from 2.303 into 0.3010. During the derivation of T half, we have seen this step. Okay, so always remember 0.693 we can split it as 2.303 into 0.3010, because then the calculation will become easier. Divided by T half, right? K is 0.693. Instead of 0.693, I wrote this much. Then divided by T half. So that T half will go to the numerator, 23.1. Okay. Then log R0 is 100, R is 25. 100 by 25 is 4. Log 4 will come. Okay. Now this I can cancel. So 23.1 divided by 0.3010. This log 4 is 2 log 2. Okay. Log 4 I can write it as log 2 square. Log A raised to B is B log A. Actually, you can use the direct answer value here and calculate, no issue. This is shortcut, so calculation will become easier. 2 log 2's value is again 0.3010. So this 0.3010 and this we can cancel. So 23.1 into 2. So it will be 46.2 minutes. So the advantage of doing this type of this way is, since they didn't ask for the K value directly, you don't have to calculate and show a value over here. So when I'm substituting this directly here, too much time can be saved for the calculation. And this log 4 also, log 4 directly you can take 0.60220. That is double of 0.3010. That way also you can cancel. See 0.6020, if you are directly substituting 0.301, you can cancel like this. Okay, so this 2 will come again. So the time taken for 75% completion is 46.2 minutes. Okay, now next question. Okay, calculate two-third life. Two-third life. Half life we wrote T half. So two-third life we can say 2T 2 by 3. Can we write like this? So two-third life we want to calculate. Again the reaction is first order. This information is very important to note, because based on this only we have to choose the equation. If it is zero order, the equation is different, right? R0 minus R by T, that's the value for K. And here already k value is given, 5.48 into 10 raised to minus 14 per second. Okay, then 2/3 life, r0 and r is not given. So what we can do is r0 let it be x. Okay, then r will be how much of it is completed? 2/3 of x is completed. So from x, 2/3 x completed. So the remaining will be x minus 2/3 x, right? Huh? So 2/3 x is completed means 1 by 3x will be remaining. 3 parts are there, 2 part completed, remaining 1/3 will be there. So that will be r. If you don't understand in this type of logic to think, then this 3 will be here, denominator 1. So 3 will be LCM. So 3x minus 2x, this here with this 3 you multiply. 3x minus 2x divided by common denominator will be the LCM 3. So 3x minus 2x will be 1x. So x by 3 is r. Okay. Anyone logically also it should come. Okay, now t 2/3 is 2.303 by k log r0 by r. Okay, 2.303, k's value substitute 5.48 into, when I'm taking this you put pause for the video and you know already. If you know, just do the substitution and check whether you are thinking in the right way. So x divided by x by 3, x by 3. So that 3 will go to the numerator. So log 3 will come. Okay. So 2.303 by 5.48 into 10 raised to minus 14. Log 3 is 0.4771, I guess. So let me check once again. Mm, 0.4771. Okay, now we have to multiply and divide. Okay, I'm not doing it now. 2.303 into 0.4771 divided by 5.48 into 10 raised to minus 14. This will go to the numerator. It will become 10 raised to plus 14. Just inform me through the comment box if I have to do the calculation also. Okay. So in that case, I will show you the calculation also. So when you are calculating, the answer will become 2.01 into 10 raised to 13 seconds. Because in the question, K's value unit is given as per second. So the final answer unit is second. Okay. Okay. Now see, next question. Sucrose decomposes in acid solution into glucose and fructose according to first order rate law. Again, that's also first order equation. T half is given as 3 hours. Here time is in hours. Don't think that you have to convert the time. No need. You can use the same hour itself. Don't waste the time by converting. Calculate the fraction of sucrose which remains after 6 hours. So here another duration of time is given after 8 hours. After 8 hours, how much fraction of sucrose is remaining? Fraction of sucrose remaining means it should be amount of sucrose remaining divided by initial concentration. The ratio R by R0 only you have to find out. Okay, fraction of something remaining. That means you have to find out R by R0. Not R0 by R by R0 you have to find out. Okay. Again, this R0 time, everything is coming in this equation. K is equal to 2.303 by T log r0 by r0 and r we don't know, but we want to find out the ratio r by r0. So for that, first we will find out this much. Again, here in this question also anti-logarithm will come. So log r0 by r is k into t divided by 2.303. And what is the value for k? T half is given, so 0.693 by t half is k. 0.693 by t half. Instead of k, I substituted this, and t over here is 8 hours, and this is for k. This much is for k. Again, 2.303. I told you in the previous problem also, 0.693 you can substitute as 2.303 into 0.3010. T half is 3 hours. Then 8 by 2.303. See, the calculation will become much simple if you split like this. Now this one, this is 0.3, so we can take it as 0.1, right? This part you approximate. Okay, 0.3 by 3 we can take it as 0.1. So 0.1 into 8 is 0.8. Okay. So log r0 by r will become 0.8. So r0 by r alone will become anti-log of 0.8. Because it's coming in the logarithm table, it's better to find out 2-3 digit after the decimal. Okay, so we have to divide it, the whole thing, 0.3010 divided by 3. So 0.1, then 0 you have to put here again. 1 alone will not work. 0 1, so I put 0 10, so 3 3s are 9. 0. Here answer is given as 0.8024. 0.231 from where did? Oh, case value they calculated as 0.231. We didn't calculate, we did 2.303 into 0.1. Like that we did. Okay. And we cancelled this. Okay. So anyway, 0.3010 by 3. Actually, 0.1003 only we will get over here. This one is also smaller, so one more 0 we have to put. Then 0.1003 into 8. 24 0 0.8024. Okay, so anti-log of 0.8024, anti-log of 0.8024 is given here as 6.345. It will be given in the question. Then here again, don't think that answer is complete now, because here we calculate r0 by r, but we want r by r0. Fraction remaining is r by r0, so we have to take the reciprocal. Reciprocal means 1 by, so r by r0 when you are calculating 1 by 6.345 we have to take. Okay, so that answer we will be getting as 0.158. 0.158. So this is the way to calculate fraction left after a given time. R by R0 you have to calculate. Okay, So anti-logarithm part, you don't worry, in the question it will be given to you. Okay. Now another type of question is, see, hydrolysis of methyl acetate solution has been studied by titrating. The concentration of the ester at given time is given at different time is given below. So 0 time concentration 0.8500. So that is the initial concentration. After 30 minutes, this is the concentration. So different time interval, different concentration is given. Show that it follows pseudo first order reaction. Okay, we have to prove that it is a pseudo first order reaction. Rate law will be, actual rate law will be like this, and you remember, I guess, water concentration will be a constant value. So this K dash into acetate concentration, that will be, that the rate law will be appearing like that. So that's why it is called a pseudo first order reaction. Okay, so here what we have to do is, for pseudo first order reaction, uh, the rate law we can apply it as a first order rate law, right? K is equal to 2.303 by T log R0 by R, because it look like a first order reaction. This K, this value of K will will be a constant value if you are applying a first order equation. Okay, so now when you are applying, you remember the first problem we did, in the same way we have to find out the different values for K. So here I'm taking 30 minutes. So R0 is at 0 time, the concentration given is R0, and at 30 minutes the concentration given is R. You will get a value for K. Okay, then same rate law you apply, and at 60 minutes you find out the value. 60 minutes log R0 0.8500 only. I hope you understood how to take the data. Okay, so like that, at 3 set of time interval, find, see, like here I'm not doing the whole calculation here. So like this, you substitute value, find the value for K. You see the value is found to be almost a constant value, right? 2 point only we are getting, 10 raised to minus 3 is also there. So every time we are getting a same value for K. That means the equation we choose over here, that is first order equation, is correct. Okay, so even though rate law is given like this, when you are according to the rate law, it should be second order, but here water is in excess, so it acts like a first order reaction, and we got, when we applied the first order equation, K's value is found to be a constant. So we can say that um, it is a pseudo first order reaction. Okay, and this constant value, here you need to note one thing. Here average value we can take it as 2.00. Okay, one value we will take 2.004. K value we took it as 2.004 into 10 raised to minus 3. Okay, here this K value is actually the first order K into water concentration. These two together constant only coming as the value for K here. Okay, this K is different from the actual first order K. This K is coming, this value when you calculated, that value is coming from the, this, see this rate law, rate is equal to K dash, sorry, K dash into ester into water, right? This water is a constant, K dash is a constant. When these two multiply only, we will get the K which we got here. These two constant value together, another constant, that value of K only we found out. Okay, so that value of K is this original K dash into water concentration. In this question, that K is given as K dash. That's why I am choosing that notation. And water concentration is given as 55. So 55 into K dash, when you are doing 2.004 into 10 raised to minus 3 we are getting. So this K dash will be 10 raised to minus 3 by 55. This will be the value for K dash, which is mentioned over here. Okay, that only they are asking what is the value for K in this equation. Okay, so when you are dividing, you will get a value like this. Hope it is clear. Okay. Now next question, rate constant for a first order reaction is K is equal to 60 per second. Again first order. How much time will it take to reduce? Time only we want to calculate. The initial concentration of the reactant to its 1/16th value. Here why I choose this similar pattern question only, but here they are not telling 1/16th is reacted. They are telling initial concentration of the reactant is reduced to 1/16th value. So if R0 I am taking it as X, R over here is 1/16th of X. That is only left behind. Okay, so we can directly apply in the equation. Here the mistake will come in this thing. Some children will subtract x minus 1/16th of x. It's not like 1/16th is completed. It's like initial concentration is reduced to its 1/16th value. That's why we should take directly 1/16th over here. Log x by 16th. So 16 will go into the numerator. Log 16 we have to take. Again, suppose in the question only log 2 is given. Log 2 or log 4, 0.6010, 0.6020, sorry. Okay, so log 16 is log 16 is 4 square. So log 4 square. So that will be 2 log 4. Log 4 value is 0.6020. Again, little bit of approximation we can do. 60.60, so we can take it as 0.10. Okay, or 60 into 10 raised to minus 2, 10 raised to minus 2 will come. So we can calculate this. The rest you just have to multiply. 2.303 into 6 into 10 raised to minus 2 will become the answer. Okay. This don't bother. This is correct only. 2 log 4. Sorry, 2 here, not 6. Okay. So when you are calculating, 4.6 into 10 raised to minus 2 seconds will come. Okay. Any part you want clarification means you can ask. Okay. So that for today. Thank you.